Good afternoon all, and for those following along on YouTube at home, good morning, good afternoon, good evening. I'm Brett Morgan. I work on the developer relations team for Google Maps based in Sydney, Australia. That means that I do things like write sample apps, write tutorials, code labs, and all that sort of thing. And as I said, I look after Google Maps APIs. Google Maps APIs is the oldest API surface that Google has at over 10 years old. We have a lot of APIs. We have a lot of interesting functionality that you can use in your applications. One of the things that we hear from developers, like yourself, is that it's great, you've got all these APIs, you've got this wonderful documentation, tells you what the arguments are, tells you what the result is, but how do I, as a developer, take all these APIs, glue them together to create something that solves a problem? So the Geo Developers Geo Developer Relations team in Sydney came up with an idea of making solutions that show you end-to-end how to solve a problem. So I just want to give you a little bit of history here. Every year, we have an annual developer conference called Google I/O. And a couple of years ago, we decided to move it from downtown San Francisco, where it had been at Moscone for quite a few years, into Google's backyard at Shoreline Amphitheatre. Now, this is great. Bigger venue means we can do bigger things, we can have more people come along. But how do you take 7,000 people from a bunch of hotels all over South Bay and get them into this one event? Well, there's a pretty easy answer to that. You rent a fleet of buses and move people around with them. But this raised an interesting opportunity for those of us on our Geo Developer Relations team. How can we best utilize Google Maps APIs to show people where their buses are and how long it's going to take them to get between different points? So Steve down in the front row here and myself and a bunch of others put together a solution that actually did this. Showed attendees at Google I/O the real-time location of their buses and also showed them timetables of how long the bus was going to take to get them back to their hotel. So what I'm going to do this afternoon is walk you through that solution. But a quick little note here, what we're building is actually an asset tracker, and that one is specifically called out in our terms. So before you go ahead and implement an asset tracker, please have a chat to our sales staff about a premium plan, because you're going to need it. Okay, let's have an overview of the transport tracker solution. So here's the architecture. For those of you who attended the Flutter and Firebase talk yesterday, this probably looks a little bit familiar. Turns out Firebase encourages you to actually build in this way, and it does a very good job. So what do we have here? Well, the first part of the problem is we have 30-odd buses running around South Bay, and we want to know where they are. So what we did is we put an Android phone on each bus with a little suction cup holder to keep the phone out of the way of the driver and a USB power adapter. And that had a custom application on it, which was then turning around and publishing to Firebase the location of the bus. Firebase is wonderful. It turns around and when you push some new information into it, it turns around and notifies anything that's listening on that path. Oops, wrong button. That button. Okay, so following on from that, we have a Node.js process running in a Google Compute Engine server in the cloud, actually being notified that this bus has moved from here to here. That process then cleans up that data and writes the cleaned up location of the bus along with timetable information and various other things back into Firebase in a different location, which then turns around and changes the display. So at Google I/O, we had big 60-inch LCD monitors that had, as you saw previously, the real-time location of the buses and timetable information. So this is the overview of the solution I'm presenting this afternoon. So let's dive in. Let's start with the first component. These are the Android phones. How do we get the accurate location of the phone using Android APIs? Well, thanks to Steve's Code Lab, which some of you probably had a go at yesterday afternoon, but if you're following along on YouTube or you didn't, I'll have links at the end of the talk that actually I'll link you to the RealTime Code Lab. But this, I just want to show you the core component of that Code Lab that drives the ability to track the location. So what we're doing to start with is configuring a location request. We're being reasonably aggressive here. We're asking for high fidelity, high accuracy of the phone, and we're asking to do it every 10 seconds. This means the phone's going to be really active. The radio circuitry is always going to be on, so this is going to have battery implications, which is why I mentioned before that when we installed the phones in the buses, we connected them up to USB phone chargers. So this is an explicit design consideration when you turn around and do this sort of thing, you need to be aware of, is this phone permanently connected to power or not? Another thing we implemented to deal with this was monitoring software. So we had the phones actually writing their battery level into another part of Firebase that we had an admin user interface so we could see all of our phones, their current location, and most importantly, their power status. Because occasionally, a bus driver would get into his bus and go, what's this phone doing here, and unplug it and plug his own phone in, and we'd go, oh, damn it. Go and find the bus and get him to plug it back in. Okay, so we've configured how we're going to get locations. The next point is that we then use the Fuse Location Provider API. This gives us fuses together cellular tower data, GPS data, and Wi-Fi data to give us a more accurate prediction as to where this phone actually is. We then configure whereabouts in Firebase we're going to write this location information. And finally, we create a callback to hand to the Fuse Location Provider API that we can actually then turn around and write the results into Firebase. And with this 10 lines of code, we are now tracking this phone in real time. Okay, so we've dealt with the first component. Now we move to the heart of the system, the Firebase Real-Time Database. The Firebase Real-Time Database is a very powerful real-time communication tool. For me, while I was developing this system, it was absolutely insanely powerful because traditionally when you're developing a distributed system, the main pain point you have is understanding what the whole system is doing. Now, because I've got 30 phones wandering around South Bay, I like to know where they are, what they're doing, and in this console, I can see what each of them is doing in real time. During development, we can also turn around and not have that component, and I can sit here and, through this console, turn around and make changes to the data structures and see what the downstream components do when faced with certain edge cases. This allows you to effectively have real-time development in a distributed system. You can see what it's doing, you can change what it's doing, all in a nice web browser-based console. Okay, so I told you about the Android phones. They put their location information into Firebase. Firebase then notifies our Node.js process running on Google Compute Engine. So this component has a couple of things that it does. It has a list of responsibilities, but I'm going to go through two this afternoon. The first one is that while we're running simulations, we like to move things around the map. To do that, we need to actually generate the paths that the buses are going to take. They start at a hotel, go to another hotel, and then wind up at Google I/O. We need to then track out the path going around all the roads, the roundabouts, over the bridges and all that sort of thing, that bus is going to take so that our simulation looks realistic. The second piece of code I'm going to show you is what this server does with the phone location information to tidy up the fact that GPS data tends to be a bit noisy. Okay, so the first code snippet. Here's where we're generating a path. Trip points is where we're going to take all the points of the path, put them into a list, and then do things with it later. So this is effectively just an accumulator. For every stop, I actually have a database of all the information of all the trips. And so what we're going to do is get the stops that this trip is going to make out of that database. Here's where we create a directions API request. At its simplest, a directions request has a starting point and an ending point, in this case, origin and destination. But in the case where we have multiple hotels that this bus is going to, we have waypoints, which are the hotels in between the origin and the destination. This is the line where we use a client library to turn around and make a request to the directions API. I just want to stop here for a second. We actually have 4 client libraries. One, as you can see here, in Node.js, one for Go, one for Java, one for Python. And these client libraries take the web service APIs that we have, like Directions API, Roads API, so on and so forth, and give you language-appropriate help. So for Java and for Go, we expose to you what the result types are going to be, so you get, if your browser or editor gives you IntelliSense, you'll turn around and get type completion, all that sort of thing. Okay, now that we've made that request, using the power of a wait to turn what's basically an asynchronous operation into something that looks synchronous, now we look at the response. Did it actually work? And if it did, now we actually interrogate the response structure. So a directions response consists of a set of routes, and I'm just going to take the first one here because I don't really care. Well, I do care. The first route is going to be the best route, right? For each route, we have a set of legs. This traditionally shows up as different transport modalities. And in each leg, there are a set of steps. And finally, within a step, we have a polyline. So a polyline is an encoded format for a list of lat longs, location points. And so I decode this encoded string. I've got the points for this step. And then I turn around and glue them all together, put them in trip points, and then I use it later for actually rendering the buses going around in the simulation. So the second code snippet, this is where I'm going to deal with the bus. So the bus is walking around, well, walking, driving, rolling around. So we have a bus. It's moving around South Bay. It's checking in every 10 seconds through Firebase and telling us where it is. So on the server side, I collect a history of the location of the bus. A couple of minutes in this case, and I take that history and I send it off to our Snap to Road API. So this is part of our Roads API service. So Roads API knows where all the roads are, and I can turn around and give it a couple of minutes of history of a bus moving around, and Roads API will then take those points, do some mathematics, and make the best guess as to which road you're actually driving down. So it effectively eliminates the noise from the GPS track. So then because we're actually interested in the current location of the bus, we take the list of returned points and take the very last one. It's worth noting here that if you're plotting out a path of something on a map, that you can also ask Roads API to insert additional points. Because, as I said, it knows where things like roundabouts are and curved roads. So you can have Roads API insert additional points in the Snap to Road result, such that when you plot it, it's a nice line that actually follows the roads, as opposed to just the points that you sampled using, say, Fuse Location Provider. In this case, we're only interested in a point. We're not plotting anything, so I didn't do that. I've just taken the most recent point. And of course, there's error recovery. So now we're on to the final part of the system. This is where we put the buses and the timetable on the map. So you might have seen the map that I showed you doesn't look like a standard Google map. Well, what's the code look like? Looks like this. We have a description language that allows you to define the set of rules that tells our mapping engine how to render a map. I don't know about you, but I don't really want to turn around and configure how a map renders using this. I'd much rather use or what you see is what you get wizard. So what I'd like to show you now is how to use our wizard to actually come up with a map. Come up with a map style. So I'll just pray that the demo gods are actually working. Okay, this is our wizard. I'd like to create a style. Sydney, Australia. Can't half tell where this was written, right? Let's go to Krakow. Okay, this is the stock standard Google Maps styling. But I'm creating an application, and I don't want this style. I want something that speaks more to Krakow. Should we go with something that's completely desaturated? Or respecting Krakow's history? Should we go with something a bit retro? I think I like this. But it's got a bunch of visual noise on it that's not talking to me with the application I'm designing. So I can then turn around and, yeah, that's better. I've calmed down the map. Maybe I want to take off the landmarks. Let's zoom in a bit. And a bit more. How's that look? I'm happy with that. Okay. If you're wanting to dive in deeper and actually make more modifications, we have a deeper level here that you can turn around and play with the individual settings and see the results in real time. But I'm happy with this map as it is. So we give you two ways of using this map that you've just configured. The first one here is the JSON language that I was showing you before. This map styling information is useful in, obviously, Google Maps for web, so using the JavaScript API, but it also works the exact same language on Android and iOS. So this way you can configure your map once and use it across all of your applications. We also give you static maps information, so if you just want to put a map on a page and configure it and style it in some way, you can do this, and this saves you from having to load the JavaScript Maps API. It's a much lighter response if you know that you don't want your users interacting with the map. Okay, back to the presentation. Okay, now I've styled the map. We're up to the final part of the journey where we've had the information start on the Android phone, we cleaned it up in Compute Engine, now we're going to display it on a map. Okay, there's no types here, we must be back in JavaScript land. We've got a Firebase database that we're taking a reference on. Now we're listening to a different path in Firebase. So this is where the Compute Engine hosted Node.js process is writing the cleaned up location of the buses. So what I've done here is that under this location in Firebase, I'm writing in an entry for each bus. So thus I can look up all the buses all at once. I look at each bus, and I've got a routine here to figure out what coloured marker to put up for this bus, depending on which route that bus is actually servicing. Then we create a marker. The marker goes on a map. Realistically, you actually need a bit more complexity here to deal with reusing markers, because if you just kept creating new markers, then you'd wind up with a screen full of markers. You actually want to move the marker around, and you want to delete it when the bus goes out of service. But I hear people out in the audience screaming, the web's great, but I want to put it on mobile as well. How can we do this? Well, just so happens, we have the same code for Java. We've got types here, we're back in Java land. We have a database reference. We turn around and create a child listener to add to the Firebase to notify us when things change. This time around, I'm just tracking a single bus. I'm not turning around and mapping all of them. I've got out of the Firebase, I've got the lat, so that's the latitude of the bus, longitude, and the bus route. So now I have enough information to turn around and configure a marker on the map. Same logic applies here. You probably want to hold on to the marker once you create it and just move it around. Simple enough. Okay, so just to go over at a high level what we've just covered. We started out in Android using Fuse Location Provider to get the location of an asset. We published that location every 10 seconds into Firebase. Firebase notified a Google Compute Engine hosted Node.js process to clean up that data and deal with the vagaries of GPS location data. That updated information was written back into Firebase, at which point it controlled a front-end Google Map hosted dashboard that was shown to all the attendees at Google I/O. I've also shown you how to do this with mobile. So where next? For starters, if you would like to see the documentation for the Google Maps solutions that we're publishing, it's all up on developers.google.com. If you would like to have a look at our client libraries and other open source code like the samples, like the solutions, it's all up on GitHub. And finally, the code that you saw in this talk is actually lifted out of 3 code labs. The first code lab was the one that Steve and I hosted yesterday, which was the real-time asset tracking code lab. The code for the Node.js process was lifted out of the transport tracker backend code lab. And finally, the code that I showed almost at the very end of putting markers on a big Google map was taken out of the transport tracker map. And with that, I thank you for your attention, and I invite you to give us feedback. Thank you very much.